All right. It's been a while since I practiced some coding, so just thought of trying to solve some coding problems live. I'll try this assessment thing. Let's do this one. We'll have around 2 questions. We'll have 1 hour to complete. Okay. All right. Given an integer n, return true if it's a power of 2. Otherwise, return false. An integer n is a power of 2 if there exists an integer x such that n equals to 2 raised to the power x. Okay. What is the range of n that is given to us? N is an integer. Follow up, could you solve it without loops, recursion, and so on and so forth? So the thing about power of 2 is that it has only a single 1 in its binary representation. And I don't know what equation it's called, but basically if you do something like n and n minus 1, then what happens is uh, you will get 0 if it's a power of 2, because n and n minus 1 basically removes the last one from the right. Right. So if you take an example, what are the powers of 2's, right? So 1, 2, 4, 8, and this is 0, 0, 0, 1, 0, 0, okay, 1, 0, 0, 0, 1, 0, and 8 is 0, 1, 0, 0. Now, if you AND them with n minus 1, so n minus 1 here would be 0. Here n minus 1 would be 1, which is 1, right? And if you AND them, you can see it will come at 0 because 1, 0, it will be, hey, is it wrong? Okay, it is wrong. So, yeah. So if you think about this, it is 1, 0, 0, so it will be 0, 0, 1, 1. Okay, that's 2 full, right? So this is 0, 0, 0, 1, this is 0, 0, 0, 0, and 8 minus 1 is 7, which is 0, 1, 1, 1. So we can see if I'm AND these two, I will get 0, right? So this, and that way it will end up removing the most significant, not the most, the least significant one from the input. So is 0 a power of 2? I would say no, right? So, but if you AND 0 with anything, you will get 0. So that is one exception. So if n equals to 0, so I think it's do something like return uh, n is not equal to 0, and then n and n minus 1. I think with this, and I have to be a bit careful. Yeah, n and n minus 1 equals to 0, and we equal this. Yeah, I think this is good enough. Now let's run code, and we get a compilation error that we can fix. Okay, for one it works. Run example test cases, it will take some more, which is good enough. Now let's confirm for 0. Okay, and then submit. And we get the wrong answer. Yeah, wrong answer, because if it's the most negative one, then you cannot do n and minus 1. So what I'll do for that is I'll get double x equals to n, and I'll change it to this. And let's see if this works. So it's bad operand. Bad operand types of binary operator. Should I make it long or something? Okay, submit, and this works. All right, so this is sort of a binary, not really an interesting. I mean, shouldn't get these sort of questions. I mean, these math binary, not very common and not very interesting. Usually, you're unlucky if you ask these sort of questions. But okay, given an array nums of n integers, where nums of I is in the range 1 to n, return an array of all the integers in the range excuse me, that do not appear in nums. Okay, so given an integer array nums of n integers, where nums of I is in the range 1 to n. Okay, return an array of all integers in the range 1 to n that do not appear in nums. I mean, I didn't really get the questions. Let's take an example. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8. So the array size is 8. So it has numbers from 1 to 8, but there are some numbers that are not there. The numbers that are not there are how many though? Multiple, right? So because there can be any number, could you do it without extra space and in O of n runtime? You may know the returned list does not count as extra space. Okay, so then it says, I don't know. I don't think I can do it. That's interesting. That if you want to do it in without extra space, really. I mean, could I use the same array as yeah, trying to use the same array as instead of using a map, can I convert this array itself into a map? So it's 1 to 8. Let's see. Basically, it's polynomial. Just make it negative. Make that index negative if it's not already negative. And the indexes. So my array size is n, 1 to n. Okay. Now what I want to do is int to index, number to index. If number is p, index p minus 1. Use negative sign to represent presence. And that's enough, right? The ones that are not negative are the ones that are missing. So we go from for int I equals to. Is there a problem? No. What is the size of yeah, this 10 to the power 5 is not a problem. So I equals to 1, I is less than equals to n, I plus plus. So first we no we go through the array, not through this. So we go through the array. So for each num in nums, right? I think that's also not fair. I don't know whether this for because we are changing. I would rather do for int I equals to 0 less than minus 1 plus plus. Num equals to nums of I. Okay, now I want to take absolute value of this. So I will do here int. I will do here math dot absolute. Okay, so I get the modulus now. Index equals to num minus 1 if nums of index is greater than 0, then we go nums of index equals to minus nums of index, right? So that way we change it to negative, and now we go through the array again. And here is where we'll return a list. So so if nums of I is less than 0 is the presence, greater than 0 is the problem. Then what you have to do is this list dot add I plus 1. Yeah, I plus 1. And then you return list. Okay, run code. 5 6 is working. Example test cases. Okay, submit. And we are done. It's generating some sort of a, okay, so both were easy problems, and I mean, no fun doing such easy problems really. Okay, let's start another one then while it does the analysis. Okay, I did the analysis, got around 80%, 7.34, whatever. Closing it off. Assessment. Okay, now let's try, come on. Let's try this set. We'll get 3 questions, we'll have around 1.5 hours to complete. Okay, now this is some big question. We are given an array of distinct integers, array and an array of integers pieces where the array integers and pieces are distinct. The goal is to form an array by concatenating the array in pieces in any order. However, you are not allowed to reorder the integers in each array pieces. Return true if it is possible to form an array you didn't understand. Let's look at an example. 15 and 88 divided into 88 and 15. Concatenate 15, then 88. But now it is distinct pieces. Even though the numbers match, we cannot order the order pieces. So I did not understand. Let's see the question again. We're given an array of distinct integers array and an array of integers pieces. We're given 2 inputs. Yeah, we're given 2 inputs. Here the input is 15, 88 and 88, 15. Okay. Where integers and pieces are distinct. Your goal is to form array. Your goal is to form array by concatenating the array in pieces in any order. Got it? However, you're not allowed to reorder the integers in each array pieces. Got it. So basically here, if this is the pieces, you take 15 and 88 and then you get this array. And here 16, 18, 49, because it's a single piece, it can't form this array because you can't reorder within it. Okay. Here you can take 78, 464 and 91. So you first take 91, then you take 464, then you take 78. It works. Okay, decent question I'd say. How do you solve it? I guess this array converted into index like a map, and then go through each piece and check whether each piece is following the same property. So within that piece, the ordering is the same as within the array. That is one. And second is, there can be a problem. Yeah, if these are distinct, then I don't have that problem, right? Distinct integers array. Yeah, that is good because these are distinct. Then I don't have the problem of. So basically, if I've already covered something, also to ensure that everything got covered. Fair enough. I think it's an easy problem, I'd say. So we generate a map. Are there some constraints? What are the constraints? Follow-ups? No. Okay, all good. Okay, so we save the indexes. Now what we're doing is we're going to the each and every piece. So for and I'll do it in two steps. I'll tell you what two steps. So you're basically counting. Okay, L equals to uh, if L is not pieces of 0, pieces of I. If L is not equals to array dot length, uh, return false. This is like a shortcut that you don't go through a lots and lots of pieces and check if just his basic condition is not even met. If the basic condition is met, then okay, we go through the pieces again. Fine, no problem. So for int equals to 0. Okay, so for each piece, right? We want to get the first element, right? I mean, if it's not empty, or it can even be empty, right? Uh, so if pieces of I the length is equals to 0, then I don't even care. Continue. Otherwise, basically now you're just checking the index if it matches its index, right? So I am at index 0. So if oh yeah, no, I think you sort of, yeah, there is no such thing as index here. You're just checking randomly, right? So you basically want to check just within the pieces if things are accurate or not. That's all. pieces of 0 dot no, pieces of I 0. And now what you want to do is if uh, cover dot contains start, then you just return false. And if it's already covered or if it's not even present in map, then you go index equals to map.cat of start cover.add start. You go this and then you go index plus plus, right? If and sort of same thing, which is now here in this start it will be some num equals to pieces of ij, and if covered contains this number or map doesn't contain this number or map dot cat num is not equal to index, then we have a problem. Otherwise we move on, we expect the next index to be this. And then we return false if this is the case. Otherwise what we do is we go cover dot add num, and at the end what we do is so we could either do covered dot, or we could do like we could remove it from the map. That's another idea that you could do. Yeah, perhaps just remove it from the map. Yeah, so I'm done here. Map dot remove num, in which case this won't be of any interest. Map dot remove start. Then I don't need this. If it is not present or if it's not in the right index, I return false. Otherwise I remove it. After I remove it, it won't be present. That means if it's occurring again, there's a problem. And yeah, and so at the end here I have to return map dot size should be 0. So this is my sort of condition. Okay, let's see, fix the compilation errors and stuff. Okay, 1588, what is the answer? It's true for that. Okay, an example test cases. We want false and then true. True, false, true. Okay, submit. Okay. Oh, we just got 2 questions, huh? Okay. Given a string as an integer k, return true if you can use all characters in S to construct k palindrome strings, or false otherwise. What? So we're given a string S. From this string S, we will take k characters. No, we use all the characters in S and construct k palindrome strings. That's an example. Annabelle, k equals to 2. We can construct 2 palindromes using all characters in S. Some possible constructions are you can construct 2 palindromes using all characters in S. I did not understand it. Anna plus Elbel. What the heck is this? I mean, yes, this is a palindrome. Oh, so you basically break it down or something like that. So you have this is a palindrome as well as and from this also you can construct a palindrome which is this. Fair enough. Another way is you can make two palindromes from this, or you can make two palindromes like this as well. So you can always make these number of palindromes. Like if 1, 2, 3, 4, 5, 6, 7, 8, 9 palindromes is easy, right? The lesser number of palindromes is difficult. Okay. So from lead code, we thought it's impossible to construct three palindromes using all characters of S. And S equals to true, K equals to 4, T, R, U, and E. Right? Fair enough. Okay, I would say this is at least a medium problem. Let's try and figure out what to do here. Given a string as an integer k, return true if you can use all characters in S to construct k palindrome strings or false otherwise. Because you can arrange in any fashion. Um, that's the trick, right? You can arrange in any damn fashion that you want. Then really it's the number of palindromes that you want. Uh, so for example, from lead code, can you construct three palindromes? Hmm, interesting. If you take all E's, that would be one. That would be probably the biggest. The biggest would be all E's. Yeah, biggest would be a three-length palindrome. Yeah. Man, this is a difficult question, man. Um, what can we do to solve this? So we can get the count of each character, right? That is an easy thing to get. So from Annabelle, you say you have to make two palindromes. Then let's look at Annabelle and let's look at the count of each characters. Okay. So we have A how many times? Two times. And then N how many times? Two times. And then B how many times? One time. And then E how many times? Two. And L two. So just based on looking at it, I can say all these two can form a palindrome, and this B alone can form a like a different palindrome. Or you can make like 1, 2, 3, 4, 5 palindromes. Is it like we figure out how many different palindromes can we make and whether K is in that set or not? So like from this I can make like 1, 2, 3, 4, 5, right? So and each character individually, right? So whatever is the length, 2 + 2, 4, 1, 5, 6, 7, 8, 9. So I can make nine palindromes. I cannot make more than them because that's still the maximum length. So and then do I solve for each and every one of them? What is the maximum length of the string? Which can be a big string, okay? But okay, mainly if it's just lowercase English characters, is it? Yeah, so 26, right? So um, because k is if k was not fixed, then I think it was easier to answer. How do you solve for k? K equals to 2. So let's see, can we make one palindrome? We can always make one palindrome. And the one palindrome that you have to choose, you would choose the guy with the smallest, right? So say I choose B, and then all of this occurs even number of times. Basically, we are really interested whether the count is even or odd more than anything else. No, I mean, yeah, I think you messed up. This is a hard question. Okay, I think I'm not able to solve it. We'll figure it out, and I think it's a good one to stop at this point, I guess. Because I cannot think of the answer. Let's see what's happening. Okay, nothing is happening. Then let's think a little bit more. I don't know if we can use all characters in S to construct k palindrome strings. Let's say the question was, can you construct 5 palindrome strings, right, from this? Then what would you say? Yeah, I would say yes, because there are 5 distinct characters. Okay, can you make 4 palindrome strings? 4. Um, okay, yeah. So I'll take 1, I'll take 2, I'll take 3, and then I can take any other 2 and make 4. Yeah, I can make 4. Okay, can you make 7? 7, okay, so I'll take this 1, and then I can take 2, 3, 4, 5, and then 6, and then 7. I think the best way to do is take single letters and then yeah, take single letters. So for I think that's how we should try to do, and then we'll see. What do you mean by single letters? So what I mean by that is let's say I'll tell you. So go for this, and then so first you create a hash map of uh, character integer. So we create the count map, and then obviously if k is greater than s dot length, you have to return false. and if k equals to s dot length, yeah, then you return true. That is fine. So now this is what I'm gonna do. Okay, which is for each. So let's go again with lead code, right? Let's do for lead code and try to see why it couldn't solve the answer. So you had L occurring once, E occurring 3 times, and then T occurring once, and then C occurring once. So O occurring just once, D occurring just once. This is a problem, right? So there are so many characters just occurring once. The character that is only occurring once, or the character that are occurring odd number of times. Yeah, this is a better one to say. The characters that are occurring odd number of times will define the minimum number of palindromes. So the minimum palindromes that you will have in this is 1, 2, 3, 4, 5, 6. You minimum have 6 palindromes. You cannot have lesser than 6 palindromes. Because if there is a string that has L, it cannot just L is a palindrome, L, T, and similarly E, what you can do is okay, E is a palindrome, right? But if it was E and T, then they cannot combine to make a single palindrome. So the number of, so you get the minimum number of palindromes that will be there is that, and the maximum number of palindromes is the, can I say it's between minimum and maximum then, that's all. No, but other than that, Uh, yeah, I think that is a minimum because if you're even, you could just add just them here and there, right? Okay, so for hchar c in map dot eset, if map dot get of c percentile 2 is equals to 1. If it's odd, then you go your min plus plus. And also if min equals to 0, come on, then you go min equals to 1. So you're saying return k is greater than equals to min, and then k is less than equals to s dot length. Between these two, are all of them possible is the question, right? Let's solve that question as well. So for example here, the length is 1, 2, 3, 2 plus 2, 4 plus 1, 5 plus 6, 7, 8, 9, right? So the minimum number of palindromes in this min equals to just 1, and which is true, right? You can make a single palindrome by having two A's, two N's, like okay, so A here and A here, and then N here, N here, and then E here, and then L L, and you can put a B here, right? So you can always make one palindrome like this. Now, so that's the minimum. Maximum is 9. Question is, can you make all from 1 to 9? So now my question is for you is for 2. So this was for 1 that you could make. Now, what do you do for 2? So I have to make 2 palindromes, right? So I'll take just this B, and then I take this A, N, everything else E, L, right? Which is fair enough. Now, can I make 3 palindromes? Yeah, so you go B, and then any random, right? So uh, 2 and then 3. So you can do AANN, then you can do EELL. Okay, so can you make 4 palindromes? So B is one palindrome, and from the remaining, can you make 4? Yeah, of course, AANN, EELL. Okay, can you make 5 palindromes? 5 is again, oh, this was, so yeah, so here you cannot make 5. Here you wanted to make only 4, so you go this, and then E and L you can always just combine like that, any random. Can you make 5? 5 is easy. B, AANN, EELL, which one is, yeah, this is 5. Can you make 6 palindromes? Okay, 6, so 1 is B. Out of this 4, you have to make 6. So you can take A twice, and then N twice. How many have you got? 1, 2, 3, 4. 1, 2, 3, 4, 5 already? Okay, then no problem. EEL, like, right? Something like this. You got 6. Can you make 7? So basically, you see, you can just hit and try, and you can basically get it's just minimum maximum. Between that, you can just do everything. But there's a problem, I think. What is the problem? For the odd case, like what I mean is, like, for this case, you will say, let's complete that. I was having some fun there. So okay, for yeah, if I have to make 7 palindromes, I go B, I go A, N. How many are there? 1, 2, 3, 4, 5. I need 2 more. So EELL. Okay. Can you make 8 palindromes? So this is what, 1, 2, 3, 4, 5, and then you can divide this 6, 7, and 8, and then 9 we can anyway see. So basically, those are possible. Now here, the min is what, 1, 2, 3, 4, 5, 6. Minimum you'll need 6 palindromes, and maximum you'll have 9 palindromes. Yeah, so min and max I think is working. So 6 is clear. Can you make 7? So 1, 2, 3, 4, 5 would be this, and then 6, 7, yes, 8. So 1, 2, 3, 4, 5. Basically, it's only 8, no? So if I, yeah, 8, 6 to 8, correct. I think I got it. So yeah, so we can just min and max. I hope this works. Let us see. S dot length has to be like this. Oh. Okay, this returns true. An example test cases. Come on. And then false. And for the last one, did we get a true? Yeah. I am slightly doubtful, but if it works, I'll be a bit happy. It worked. Fantastic. Was it an easy problem? Was the second one an easy problem? No, it is a medium. Okay. Yeah, I think this is a good point to stop. Spent around how much time? 40 minutes, 45 minutes practicing is a good one. Yeah, you don't get that a great score, but okay. Should we see the solution for this problem perhaps? If there's a better solution for this. I don't see a solution. I can see my submission. Where does my submission stand? Not that great. Uh, Let us see some random. Okay. Yeah, odd equals to 0, count equals to 96. Yeah, I mean, the logic is same. Logic is exactly the same. Odd is less than equal to 2. Yeah, basically getting the odd count. Yeah, the only thing is, okay, I use a hash map. I could have used this 26, and that would, you don't have to do the hash mapping and it would just be efficient. But logic is same, so I'm happy. Alrighty, we can stop here.